Good morning, third grade. Our target for today is I can identify the parts and wholes in a put-together problem, and I can solve put-together story problems with a missing part using a bar diagram. Put-together problems are problems where there are two amounts. There is no action, and the two amounts are put together to make a new amount, the total. You know that in a put-together problem, the two amounts are both parts. No action happens, and then the two amounts are put together to make a new amount. The new amount is the result amount. It is the total. It is the whole. Put-together problems are problems that have no action. The two amounts are simply put together or combined. This is different than the other problem type we've learned about this year, get more. Get more problems have a get more action. Put-together problems have no action. They're simply two amounts that are put together. When we are solving put-together problems, sometimes we'll actually see the words put together in the problem. But oftentimes there are other words that tell us in the story problem that two amounts are being put together or combined. Some of the words that we might see in a put together that mean put together or combine are share, combine, all together, in all, in total, grouped, or put together. We represent put together problems using a bar diagram. Bar diagrams represent a whole and parts. The parts go inside of a bar diagram. Oftentimes there are two parts, although there can be more than two parts inside of a bar diagram. The whole always goes on the top. The parts of a diagram, the parts of a problem are equal to the whole. Part plus part equals whole. Whole minus part equals part. Go ahead and take a look at this bar diagram. We can see that the whole is 10 and one of the parts is 7. The other part we do not know, so there is an n to represent that unknown spot. When we are missing a part, we have to subtract because whole minus part equals part. The whole minus the part that you know equals the part you do not know. Let's go ahead and solve this problem to figure out what n equals. Our whole 10 minus 7, the part we know, will equal n. Think in your brain. What is 10 minus 7? 10 minus 7 is 3, so n equals 3. You already know that a put-together problem is a problem where there are two amounts. The two amounts are the parts. Those two amounts are then put together. The amount gets larger, and that is the whole. We use a bar diagram to represent our put-together problems, and we either add or subtract to solve the problem. When a whole is missing, we add because part plus part equals whole. When a part is missing, we subtract because whole minus part equals part. You already know from our target today that we're going to be solving put-together problems with a missing part. So today, we will subtract whole minus part equals part to solve the story problems. Some key words that you will see in put-together problems that help you know that they're put-together problems are words like combine, put together, in all together, or total. Today we're going to be solving put-together problems that have a missing part. One of the amounts will be unknown in the problems we're solving today. Sometimes in put-together problems, we do not know one of the parts. You can see here that the first part we don't know. We can't see it. But the second part is 3 teddy bears. The two amounts are an unknown amount and 3 teddy bears. Those are the two amounts. Those are the two parts. No action happens in this put-together problem. The two amounts are simply put together to make a new total amount. You can see that we do not know one of the amounts. We know the other amount, 3 teddy bears, and we know the result amount, 5 teddy bears. The unknown piece of information is a part. We do not know one of the amounts. We do know the other part or amount, 3 teddy bears, and we know the whole or result amount, the 5 teddy bears. If we wanted to solve this problem, we could use a bar diagram. We know that one of the parts is unknown, so we'll put n teddy bears there. The other part we do know. It's the amount, 3 teddy bears. The whole we also know. After the teddy bears are put together, there were 5 total teddy bears, or 5 teddy bears in all. So our whole is 5 teddy bears. In this problem, a part is missing. How would we solve a problem with a missing part? Would we add or subtract? Oh yes, when the unknown number is a part, you subtract. When the unknown number Oh yes. When the unknown number is a part, you subtract, because whole minus part equals part. Here you can see that same bar diagram with 5 teddy bears in all, the whole, 3 teddy bears, the part we know, and n teddy bears, the part we don't know. To solve this problem, we would subtract. The whole, 5, minus 3, the part we know, equals n. Think in your brain, what is 5 minus 3? That's right, 5 minus 3 is 2, so n equals 2. 2 teddy bears is the unknown part. Today we're going to be using our problem-solving process that you're already familiar with to solve story problems. You know that the first step of the problem-solving process is to read and understand the problem. You know that third-grade mathematicians often read a problem 2 or 3 or 4 or maybe even more times to fully understand the problem. When we're reading, we're looking to find what information do we know, and also what are we trying to find out. After we've read and understood the problem, the second step is to plan. We determine the problem type, although today you know it's put together, and we organize the information. Put together problems are organized using a bar diagram. Step 3 is to solve the problem. We choose an operation. Do we add or subtract? And then we solve. Finally, our fourth and final step is to look back and check. You look at your work and your answer and you ask yourself, is your answer reasonable? Here's the problem we're going to solve together today. Wendy has a coin collection with 56 coins in it. She has 32 silver coins and the rest are gold. How many gold coins does Wendy have? We're going to start with the first step of the problem-solving process, reading and understanding. We're going to ask ourselves, what do we know? What is the information they give us in the story problem? We're also going to ask ourselves, what am I trying to find out? What is the question asking in this story problem? We'll also figure out which pieces of information are the parts or amounts in this put-together problem, and which piece of information is the whole. Let's read this problem again and focus on finding the information they give us in the story problem. Wendy has a coin collection with 56 coins in it. She has 32 silver coins and the rest are gold. How many gold coins does Wendy have? The first piece of information that I see in this story problem is that Wendy has a coin collection with 56 coins in it. Can you find the other piece of information in this story problem? Yes, the other piece of information that we are given in the story problem is that she has 32 silver coins. Let's read the problem again and look to find the question or what it is we're trying to find out. Wendy has a coin collection with 56 coins in it. She has 32 silver coins and the rest are gold. How many gold coins does Wendy have? What is the question that this story problem is asking us to solve? You're right. The question in this problem is, How many gold coins does Wendy have? Let's go ahead and look at the information they give us and the question. We're going to look at these pieces of information carefully. Look for key words and figure out which pieces of information are the amounts or parts in this put together problem and which piece of information is the total. Look at this first piece of information, coin collection with 56 coins in it. What words are helping us know if this is one of the parts or amounts or the whole? Oh yes, I see that it says coin collection. I know that a coin collection would include all of the coins, so that is my whole in this story problem. 56 a coin collection with 56 coins in it is the whole or result amount. Now think about the piece of information, 32 silver coins. We know that the whole coin collection is the whole. Do you see any key words in the piece of information, 32 silver coins, that helps you know that that is a part? Oh yes, the words silver coins help me know that this is a part. Silver coins would be some of the coins in Wendy's collection, but not all of them. So silver coins help me know that this is a part. Now look at the question. How many gold coins does Wendy have? Do you see any keywords there that are helping you know if this is a whole or a part? I agree. The words gold coins help me know that this is also a part. I know that she has a coin collection. Some of the coins are silver and the rest are gold. So the question is asking me to find the gold coins. That's one of the amounts. So this is one of the parts. Now that we've figured out what information is the whole and what information are the parts, we can now move on to the second step of our problem-solving process. Step 2 is to plan. We're going to determine the problem type, although we already know it's put together, and we're going to organize the information into a bar diagram. When I look at this problem, I know that it's a put together problem because there are two amounts, silver coins and gold coins, and they're being put together into a coin collection, which would include all of the coins. There is no action, so I know that this is not a get more problem. The two amounts are simply being put together, so it is a put together problem. Let's read this problem again and let's think, what should we label the whole? I'll go ahead and read just the information we've determined is the whole. Coin collection with 56 coins in it. What words could we use for our whole? I probably need to use the word coin collection and definitely the word coin. I think I'm going to label the whole in the bar diagram total coins in the coin collection. Now let's think about the parts. Look at the part 32 silver coins. What word should we use to label that? Yes, we should label this part silver coins because that's how these coins are different from the other ones. They're silver. What should we label the other part, the part that we don't know? How many gold coins does Wendy have? I agree. We should label this gold coins because the fact that these coins are gold is what makes this amount different from the other amount, silver coins. Now that we've labeled the whole and the parts in the bar diagram, we can go ahead and put the numbers in. What is the number for total coins in the coin collection? Look back up at the story problem and think, how many total coins are in Wendy's coin collection? You're right. According to the story problem, Wendy has 56 coins in her collection. So I'll put the number 56 in the whole of my bar diagram. Now think about the part or amount, silver coins. Look back at the story problem. How many silver coins does Wendy have in her collection? You're right. Wendy has 32 silver coins. So I'll put the number 32 in the part labeled silver coins. Finally, think about how many gold coins Wendy has. Look at the story problem. How many gold coins does Cindy have? Look at the problem. How many gold coins does Wendy have? You're right. We don't know how many gold coins Wendy has, The question is asking us to find how many gold coins Wendy has. So we will use N to represent the unknown in this problem, N gold coins. Now that we've planned our put together problem using our bar diagram, we're ready for step 3 of our problem solving process. Step 3 is to solve. We'll look at the bar diagram and see what information is unknown so that we can choose an operation. Then we'll solve the problem. Look at the bar diagram. What is our unknown? Is it the whole or one of the parts? Yes, our unknown is a part, the amount, N gold coins. I want you to think, when a part is unknown, do we add or subtract? Think about what you know about wholes and parts. When a part is unknown, do we add or subtract? Yes, when a part is unknown, we subtract, because whole minus part equals part. We are going to write a subtraction equation to solve this problem, because when we do not know a part, we subtract to find the answer. We're going to write our equation together using both numbers and labels so that we are really thinking about what each number means. We're going to start with the whole because we're writing a subtraction equation, a whole minus part equals part equation. Look at the bar diagram. What is the number for the whole? Yes, 56 is the whole. Think about what this 56 is. Look back at the bar diagram. What label goes with this 56? That's right, 56 total coins in the coin collection. Now, we are going to subtract the part that we know, because this is a whole minus part equals part equation, and we want to find our unknown. Look at the bar diagram. What is the part that we know? I want you to think about both the number and the label, so you're thinking about what that number means. What is the part we're going to subtract? Yes, we're going to subtract 32 silver coins because it's the part that we know. To solve this problem, we'll do 56 total coins in the coin collection minus 32 silver coins. That's going to equal our unknown. Look at the bar diagram. What is our unknown? Yes, N gold coins. We'll subtract 56 total coins in the coin collection minus 32 silver coins to equal N, the number of gold coins. I know as a third grade mathematician, when I want to subtract, I write the problem vertically, lining up my ones place and tens place. Here you can see I've done that. I've written my problem vertically with 56, my whole on the top, and 32, my known part on the bottom. I'm going to subtract 56 minus 32 vertically. I will start in the ones place. 6 is the whole in the ones place, and 2 is the part in the ones place. 6 minus 2. Think in your brain, what is 6 minus 2? Yes, 6 minus 2 is 4, so my answer in the ones place is 4. Now I'll go to the tens place. 5 is the whole in my tens place. 3 is the part in my tens place. 5 minus 3 is what I need to solve for the tens place. Think in your brain, what is 5 minus 3? Yes, 5 minus 3 equals 2, so the answer in the tens place is a 2. I can see when I subtract 56 minus 32, the answer is 24. This tells me that N gold coins equals 24. So I'll write that down here with my equation and also add it to my bar diagram. N equals 24 gold coins. The last thing that we need to do to finish solving this problem is write the answer in words. Sometimes when I'm solving a story problem, I work so hard on solving it that I kind of forget exactly what the question asks. I know that I want to write an excellent answer that restates the question and uses words from the problem in my answer. So I'd better go back and read the question. The question in this problem says, how many gold coins does Wendy have? How could we restate this question? Think about that in your brain. What might our answer sound like? To answer this problem, we could say, Wendy has 24 gold coins. The last step in our problem-solving process is to look back and check our work. We're going to look at our work and our answer, and we're going to ask ourselves, is our answer reasonable? Let's go ahead and look back and check this problem. I like to start with my bar diagram and make sure that the numbers I put in my bar diagram match the story problem. My whole was 56 total coins. Yep, that matches the story problem. And the part I knew was 32 silver coins. Yep, that matches the problem. Because a part was missing, I subtracted 56 minus 32. 56 was my whole, so it should be the largest number. 56 is the whole, 32 is the part that I know. 24 was my answer, the other part. Both 24 and 32, the parts, are smaller than 56, so this is a reasonable answer. Finally, I'll reread the question to myself. How many gold coins does Wendy have? And I'll make sure my answer restated the question and had the correct answer in it. Wendy has 24 gold coins. I can see that I've restated the question and that I've included the correct answer, 24. We have looked back and checked third grade, and our work and answer are reasonable. Thank you for solving this put-together problem with me today. Have a wonderful day, third grade.